Good morning, everybody. We are on the second review assignment for you guys. So this is going to be our lecture video. What did I name it? Lecture video practice number 2. We're just practicing some things. I'm trying to see what you guys think, how it works out. So today I wrote them a little differently. So hopefully we can do this just a little bit better than I did yesterday. So Pythagorean's theorem, you guys are pretty well versed with this. Pythagorean theorem. A squared plus b squared equals c squared. Just remember there's a couple of key details. The sides are always across from the angles. In other words, a lot of people ask me, hey, look at big letter, angle A or big letter, capital A. It is always across from the side that is labeled lowercase a. So just understand that they're always across from each other. Angle B, represented by a capital letter, is always across from side B, which is represented by a lowercase. So just remember that's the difference between lowercase and uppercase letters. So they represent angles, and they also represent the angle and the side opposite the angle. Oh, my hair is driving me nuts today. Remember, when you use this, you're going to need 3 things to make use of the theorem. Number 1 is you need to have 2 sides, and you have to have 1 right angle. So you always have to have a right angle. So C is always got to be 90 degrees. Remember, that's a 90-degree angle. And you have to have 2 of the 3 sides. If not, we can't even use the theorem. If you're missing one of these things, we're kind of out of luck. And then we work into trigonometry, which is what we're doing next. So I'm going to scroll down to the next piece here. This is the end of the notes today. So this is from number 16 here on whatever page we're working on. I can't remember, but it's on the top of the paper here. Don't forget to always draw your triangle. It's actually a little bit better. This one here is drawn in the book. They put like a flagpole on top, and that was a horrible attempt at a flag. So we'll just kind of forget that. And then the problem states that the flagpole is 30 feet high. She's standing away. I can't remember her name, but she's standing 15 feet away. How far are her feet from the top of the flagpole? Well, number 1, most people don't want to know how far apart their feet are away from the flagpole, but that's how they try to make it lifelike. So it doesn't matter. Make sure you draw your triangle. You label. Always label. It doesn't matter what you decide to do. So let me go back up here real quick. This here, A and B can be switched. So we can have B down here, and then B would be this side. We could have A up here, and A would be this side. C always is the hypotenuse and the right angle, but A and B can be either side. So don't stress out if somebody labels A and B differently than you do. It doesn't really matter. So down here, I labeled this A and this B. So it doesn't really matter in general. So I have one side is 30. I have one side is 15. I have a right triangle, so I can always utilize this theorem. So we just plug it in. C squared equals 30 squared plus 15 squared. And you kind of do the math, use your calculator, use Desmos, whatever you need to do. And this sign right here, that one there, is approximately. So C equals approximately 33 and a half feet away from the top. So her feet are 33 and a half feet away from the top. So that's kind of how you deal with Pythagorean's theorem. You also can use it to prove if it's a right triangle or not. One of the ways is you don't know if you have a right triangle here, but they give you 3 sides. So all you do is plug in side C it's always your longest side C, into the theorem, your A and your B. You calculate both sides, and if they equal each other, it's a right triangle. If they do not equal each other, it is not a right triangle. So since 64 does not equal 74, it is not a right triangle. So that's just a real quick lecture for you guys, just to make sure that everybody's on the same page. And we will see you guys soon.